Good morning, everybody, or good evening. I'm amazed to be sitting here talking to everybody on the other side of the world, and I'd just like to thank Ashish and Cheryl for putting all this technology together to make it happen. This morning, I want to give everybody an overview of ModelMaker, what ModelMaker is, how it came about, and although I understand several of you are using the software, some are more experienced than others, what I intend to do is give everybody a brief overview of the software and show you how you can use it in the classroom to promote the use of STEM in your lessons, whether it be science, design, or mathematics. When ModelMaker is first started, it will start up in quite a basic mode, just showing a few tools. And one of the things that I like to do before I start doing any work is to set the program up and how I like it. And for my own preference, I'd like to go to the Fablab Tools menu and choose either the standard or the advanced tools. And when I press the button, you'll see more tools in ModelMaker become available. And I recognize that many users are using a small screen. So I'm also going to go to the Fablab ModelMaker Preferences, and inside Preferences choose Toolbars and make the tools small. And in that way, the smaller tools will fit onto your screen, even on a small laptop. Okay, so here is ModelMaker, and just a little history. Cheryl said that I've spent 20 years in the Navy as an engineer, and that was a very rewarding career. But when I first started, engineering didn't really mean much to me. And I can remember talking to Cheryl back in Hawaii about how when I was at school, I would learn mathematical functions parrot fashion. In other words, I would learn formula. The volume of a cuboid is length times height times width. And I would learn that kind of thing parrot fashion. And I was good at remembering formulas like that, and I could pass all of the exams. So the volume of a cuboid is length and times width times height. I could get that one right. And later on in my math class, I would learn things like 2 squared and 3 squared and 3 cubed, and I could get all the right answers but never understand what it meant. And when I left the Navy, I had a much deeper understanding of engineering, and deciding what to do with a future career, having decided to develop software, we thought we'd put some of those experiences into practice by designing a software that would help people like me, when I was a youngster, learn technology and maths. And David will expand on that later when he teaches us all to put E into STEM. An overview. ModelMaker is a 3D software. It's really a software for manipulating shapes like cuboids, cylinders, spheres, and cones. And you can see all of those shapes on the menu, on the toolbar, on the left-hand side of the software. There's quite a few different shapes, and some of them have a drop-down menu. The regular prism, for example, I don't know if you can see that yet, but a regular prism could be triangular-based, square-based, pentagon-based, and so on. So where a shape, a 3D shape, has different variants, ModelMaker will provide for that. The left-hand side of the screen is where we draw our 3D shapes, and the right-hand side of the screen is where the 3D shapes are flattened out to show their development or their net. Let me demonstrate that with a cuboid. I'll select the cuboid tool. I'll bring that tool onto the screen, click to fix the first point, drag the mouse, click to fix the second point, drag the mouse again, and click to finish the cuboid. And you can see the cuboid is rendered in 3D in the left-hand side of the screen, and the 2D net is rendered on the right hand. Now, a few minutes ago, I was talking about the fact that I was really good at remembering formulas and not really understanding what they were. And since we've been demonstrating ModelMaker to teachers and to children, we found that just using a cuboid speaks volumes about what the program can do. I don't know if everybody in the room has seen Star Trek. I know Cheryl has, because she's seen me do this before. But in Star Trek, it's a popular space program that children are quite familiar with. There is an alien space race called the Borg, B-O-R-G, and they fly around the universe in Borg spaceships, and they are cuboid in shape, and they look like this. This is a Borg spaceship. Okay. So when I was a youngster, I would learn the volume of cuboid by multiplying length and height and width and getting the right answer. But in this example, I can make a Borg spaceship of a certain dimension, print it out, and build it so I have a physical spaceship in my hand. And the great thing about this Borg spaceship is that it has corners and lines, phases, volume, area, vertices, depth, width, height, inside, outside, and all manner of things. It's even got texture. And so the humble cuboid, once you make one and put it in your hand, there's so much more that you can visualize and understand. So in my day, although I remember that formula, length times width times height, was very important, I truly found it perplexing and quite tedious. But as soon as that cuboid was given a purpose, it gave the whole subject a purpose and a relevance. If I was to ask a youngster to make a wooden box, I'm just finding some wood. If I was to ask a youngster to make a wooden box to put his toys in, the first thing he's going to have to find out is, well, how big has it got to be? So he's got, or she has got to apply dimensions to it to actually design that box. And here's the wooden box on the screen, and the net on the right-hand side, which you can print out and build. Let's have a, while that box is on the screen, I'm going to choose a different texture to put onto it. I'll open up the palette window and find wood, cover that cuboid with wood. Then I'm going to use the select face button and just select the front face and render that front face with a different piece of wood. So here is just a humble cuboid, and here it's represented by a chest of drawers, but it is something that is familiar and tangible. Youngsters like to build something like this, and they get to learn the math at the same time. And that's what I would call putting STEM into mathematics. Well, and before I look at more tools, I want to remain with the cuboid, and this time, let's just make a shape. I'm going to create a circle. There's a tool at the very bottom of the left-hand toolbar. When I click it, it brings up the Create Shape Assistant. And in there, I'm going to pick a sphere. And a sphere is generated on the screen. Just to make it easier to see, I'm going to open up the palette and color the sphere. Right, now this is just an object on the computer screen. And we found it useful when teaching in classrooms to use an exercise like this to help a pupil understand what it means when you say 1 squared is 1, 2 squared is 4. Okay, and so let me make 2 of these objects. I'm going to click on the clone button, which is on the bottom toolbar. That will clone the object you can see on the screen. I'm going to put my mouse on one of the horizontal blue handles and drag the cloned object so it's sitting next to the original one. So now we have 2 objects. I'll do the same again to form a square. Click on the clone. And then that has cloned those 2 objects to form a square, and in that square there are 4 objects. So what I've done, I've got 2 objects on the side, turn it into a square, and there are 4. 4 squared. Sorry, 2 squared is 4. How about if I select all of those objects by dragging the mouse over them all, and I hope by now that you can see those 4 spheres are selected. I'll clone them again by clicking on the clone button on the bottom toolbar. This time I'll use the blue handle that is running vertically and clone those objects to make a cube shape. So there is a cube shape which tells me that my first two objects were turned into a square, so 2 squared is 4. Now I've turned it into a cube, and I can count them. There's 1, 2, 3, 4, 5, 6. There's 8 objects in that cube. Now, it might be easier to see if I did that with squares. To save time, I'll just open an object with squares in it. Unfortunately, they are still circles. However, I hope that you understand the point. I'm going to delete the square now and open the secondary window which displays the nets. And on that window, I want to display the net of a cuboid. I'll select the cuboid again, click to start the cuboid, click to fix the bottom face, and click again to make the whole cuboid. And as soon as the cuboid is complete, the net of the cuboid will appear on the right-hand side of the screen. And we can do that with all of the other shapes. Here's a cylinder. Click on the cylinder shape. Click to start. Click to fix the bottom base. Drag the mouse. Click to fix the top base. So now we have a cuboid and a cylinder on the 3D side, and the net of the cuboid and the net of the cylinder on the right hand side. And when those are printed out, they can be cut either with scissors or with the cutting machine to be built. Back to a bit of mathematics. Here's a cylinder. Well, let's do this with the Shape Creator system. I'll open the Shape Creator system, and I want to make a cylinder radius 1 inch and height 4 inches. Now, I'm not sure if you guys who are listening in are trying to follow with their own model maker. Just to let you know that quite shortly we'll do an exercise jointly where we do make a design which we can print out and build later. Now, here is a cylinder 1 inch in radius, 4 inches in height. And that cylinder will have a certain volume. I can't remember what the formula is, so I'll right-click on the cylinder, go to Properties, and a Properties window for that cylinder will appear. It shows the radius, diameter, areas, and it shows the volume. It seems that the volume of this cylinder is 12.56 cubic inches. And I can display the formula for it as well. And the formula here, quite a lot of math on the page, but at the bottom, the formula is pi r squared times h, and pi r squared is the area of the circle, and h is the height, of course. Now, what I want to do is make a cone, and I'll use the shape creator system again. Make the cone 1 inch in radius and 4 inches in height. So on the screen now we have a cone and a cylinder. Now I want to turn them over to see, it'll be easier to see. So I'm going to select them both, right click on the selection and bring up the rotate object option. I don't know if you all see that now. I'll click rotate. The secondary window appears, and I want to rotate everything about its z-axis by 180 degrees. I'm going to click it now, and the whole design will rotate by 180 degrees. So, there on the screen, there is a cone and a cylinder. Just organising it so you can see it a bit better. Now, here's something that we do in the classroom. We make a cylinder 4 inches high and with a radius of 1 inch, and make a cone 4 inches high with a radius of 1 inch. And we invite the pupils to take a guess as to how much rice or sand will fit inside each one. And it's quite surprising, really. A lot of youngsters say, oh, they take a guess and they say we can get this much rice in the cylinder and about half as much in the cone. And the class as a whole then make the cone and the cylinder for real and fill them up with sand and rice and work out how much both of these objects contain. And then they can go away and check what they've learned in practice with the formula they've been given. And I think that the cone will contain 1/3 of the amount of rice that the cylinder would contain. I put the screen back to normal now. Now, here's a couple of tips for teachers who have already started using ModelMaker, because you're going to oversee all the pupils using the software for the first time. So I've reset the program to how it looks when I first start it. And one of the first lessons that I would recommend would be to make your shapes not too big, and to make them quite close to the center of the screen. And here's why. I'm going to make a cuboid. And it's quite a big one. And because it's so big, it's hard to see and it's quite unmanageable. And on the right-hand side, you can see that it's covering 6 sheets of paper. I'm going to make it small. So now I've made the cuboid smaller, and it's much easier to see, but you can see that I've put it on the edge of the grid. And when I move the design around using the rotate arrows, it's quite difficult to manipulate. In fact, look at that, it's disappeared. So let me go back to the beginning and put my cuboid, build my cuboid in the first place around the center of the screen. So when I set out using ModelMaker, I would recommend making objects of a fairly small to medium size and placing them in the center of the screen. Now, when I rotate the screen to look at the different sides and angles, it's very, very easy to control and to see. Now, I know that over the internet this is probably looking quite gludgy, but on my screen, let me assure you that it's easy and smooth and intuitive. Every time I create an object, like a cuboid or a cylinder or a cone, it always sits on top of the blue grid that you can see on the screen. The cuboid is already there. I'm going to add a cylinder. I've made a cylinder, and that is also sitting on top of the grid. I'll make a cone, and the cone is sitting on top of the grid. Now, if I use one of the camera buttons to see the front view, you can see that all of those shapes are the same height. They're all sitting on the same grid plane. If I go back to where I started, you'll see that they're just sitting on the grid. So while I'm there, let me just show you what the other camera positions do. You've seen the front view. Here is the side view. Here is the top view. And if you like, you can even click on the Go In button, which is in the same part of the toolbar of the cameras. I'll click Go In, and we can go inside the design and take a little walk around. I'm just setting up again to get back to the humble cuboid. There's a couple of other buttons that I'd like to show you. imagine that I've got a large design on the screen, and I wanted to have a look at this little cuboid sitting over on the left. I'll just give it a moment so that you can see it on your screen. If I select that little cuboid and click on the button that it's got a camera and a blue cuboid on it. I'm displaying it at the moment. It's on the top toolbar next to the quite close to the zoom buttons, and it's called Look At. I'll click on Look At, and that part of the design will take center stage in a close-up view for you to have a look. Now, while we're there, has anybody noticed that all of the shapes I've shown so far have been in the perspective view? Perspective is the best way to describe that, I suppose, is like looking down a railway line. If you stand on a railway line and look into the distance, the rails seem to converge, and you can see the real view, the true view, or the perspective view. Now, in ModelMaker, we show the perspective view, and that's highlighted by the right-hand button on the toolbar. But it will also show a view which represents the real dimensions of the object, the orthographic view. So, in this picture here, in this view, there is a display of a cuboid, and all of the dimensions of that cuboid are exact, and yet it looks so wrong. The back of the cuboid looks too big. But it is real, and this is why we've included the perspective option in ModelMaker to make things look real. And the way we've done that is to apply the railway line effect. The back parts of the object are smaller in dimension than the front parts.
Okay. At this point, I'll ask the teachers out here at MIC if they have any questions for Nick. The talk button before you ask your question.
Could you show where the face select tool is again?
Of course. Can you see the ModelMaker on the screen?
I can see it.
Yeah.
Okay. Can you see the grid tool, which is on the very top toolbar on the right?
Yeah.
To the left of that is the rotate button.
Right.
And to the left of that, there are two arrow buttons. One is the select button, and the one in the middle, there's a small select button pointing to a polygon. And if you click on that button, which I'm going to do now, what happens is that the object on the screen becomes opaque. Then I can take the mouse and click on one face and highlight that one face only.
Right.
Can you see that on the screen?
Yeah.
My question is Fablab ModelMaker software going to be available for iPads?
Okay, good question. It's the question that Ashish asked us about 12 months ago. and we simply weren't resourced at the time. However, we are engaged in projects at the moment which require that we resource ourselves with iPad development expertise. And during the past week, we've been talking with our local university, who are also very excited about the prospect of having such an application on the iPad. Now, it will not be a quick development, and no concrete plans have been made yet. But the way things are moving, we are planning to develop the iPad. Could I ask you if the question are you implying that you're going to be using iPad in the classroom and would like to see this as an app to use with the cutter?
Well, the reason I ask is because when I look at the way you manipulate things here, it just seems that it would be a lot easier to do on an iPad where you can just kind of use your fingers instead of using a mouse.
Yes, I think that could be made quite intuitive. And in fact, I haven't been using the mouse this evening because I thought it would be easier for presenting, but I've since unplugged it and I'm using a tracker pad instead because I find that more intuitive. And it follows that iPad would be just so. All I can say is that we are talking to people to bring them in for iPad development, and I would simply ask that you be patient with us and watch this space. I know that Cheryl, Ashish and team would like to see that development come to fruit.
Thank you, Nick. Nick, Peter Yin from Kalakaua has one more question. Peter?
Hello, Peter.
How do you shrink the two bars again?
Okay. The Fablab model, I'm using a Mac at the moment. Are you using a Mac?
PC.
Okay. On the Mac, the Fablab ModelMaker, when I open that up, which I have at the moment, it reveals a preferences option. Can you see that?
Yes.
I click preferences, a window is displayed, and in that window there is a slider bar to make the tools small or large.
Okay, I see it on a PC now.
Yes?
Thanks.
Okay. Okay, Ashish?
Thank you, Nick. Anybody else?
Okay.
Okay, looks like we are ready to move on, Nick.
Okay. Well, just very quickly, I'll get my screen back to the beginning. And I think
just one more question from Matt Hughes.
Certainly.
From Big Island.
Fire away.
Matt, if you can ask your question.
I was just trying to hit the applause button and to mahalo Nick for a great presentation.
Wow. Okay, thank you, Matt.
Thank you, Matt. All right, Nick. Are we ready to move on?
Yes, we are. I apologize that we're I'm pushing it for time. What I wanted to do is just I've been using simple shapes, cuboids, spheres, cones, cylinders, and in a few moments I'd like us to think about how we can design something for real using a few of those shapes. But before we do so, I want to show you some of the models that you can make out of simple geometric shapes. And my favorite, let's see, no, here we are, the pyramids. Here's a model of the pyramids in Egypt. And it's something that you can use in a project. It's familiar. Children understand what pyramids are. And it's a very easy project to overlay on a math lesson that starts to talk about these kind of shapes. I'll give that image a chance to settle on your screen, and then I'll move on. And this design, it is just one shape made 3 times, and you can see how the nets have been laid out, and you can print them out and build them. Now I'm going to show one more model, which is my all-time favorite. It's called Saturn V. And Saturn V is made just from cylinders and cones. And you can see how the nets are automatically arranged on the pages on the right-hand side. Now, Ashish, can people see me?
Yes, Nick, we can see the model.
Yes, Nick, we can see the model.
Okay, and here it is.
Oh, wow.
Oh, wow.
Can you see that? Okay?
Oh, yes, I can see very happy faces here.
I can see very happy faces here.
Yes. We've made quite a few of these. People keep on, they take a fancy to the model and ask us if we can leave it behind. One time, it might have been coming to Hawaii, I got stopped at the Los Angeles Customs where I lost the model. It's a very, very familiar model. It's very popular, and one can make this in the classroom using cylinders and cones and do it in a collaborative way. One group can make the first stage, one group can make the rocket engines, another group can make the landing module. So I would recommend that as a challenge for later on in the year. Okay.
This looks great, Nick.
This looks great, Nick. Okay, we've only got a short time left, but it's time enough. If everybody has got a ModelMaker in front of them, it's time enough to use some of the presentation that I've already shared to design and build a grain silo. Now, I don't know if you have grain silos in Hawaii. We don't have many in the UK, but there are plenty on the US continent. And the grain silo that I would like to make is one that will hold the grain, and it would be one where a truck could drive underneath it, and the man could pull a lever and all the grain would come out of the bottom of the silo and fill up his truck. And rather than try to guide everybody through the process and do it parrot fashion, what I'd like to do is just design one for myself very quickly and let you guys carry on and make one for yourself in such a way that you can see the shapes on the next window, you can print them out, and you can build them. And I'm going to choose to use the Shape Create Assistant, which is the button on the left-hand toolbar at the bottom. I'll use that to make a cylinder. Now, I know this, how big a cylinder I can make to fit on a page, so I'm going to choose 1 inch for the cylinder radius and 3.75 inches for the cylinder height. There's my cylinder. It looks quite big there, so I'm just going to zoom out a touch using the zoom arrow. Now, when I finish off, when I have the next shape to make the grain silo, I'm going to use a cone. And when we presented the cylinder and the cone before, if you remember, we made the cylinder sit on the grid and we made the cone sit on the grid. But this time, I want to put the cone on top of the cylinder. So before I click any buttons, I'm going to place the mouse. I've selected the cone shape and I'm placing the mouse on top of the cylinder shape that already exists. And when I do that, you'll see some little hot spots suddenly appear. Can you see them now, Ashish?
Yes, Nick, you can see them.
Yes, Nick.
Good. Okay, so before I click any button, I want to start, because I want my cylinder and the cone to line up perfectly, I'm going to move the mouse over one of those hot spots until it turns red. There we go. And so my mouse is now locked on to that hot spot. I'll click the mouse to set the first point of the base of the cone, and then move the mouse to the hot spot on the other side of the cylinder until that turns red. It's turned red. So to set the base of the cone, I'll click the mouse again and then move the mouse to provide some height. And I'm going to make it 2 inches high. Now, I'm going to delete the cone and do that again to give everybody a second look. At the moment, I've got just my cylinder on the screen. It's 1 inch radius, 3.75 inches high. I'm selecting the cone shape. I'll move the mouse over to where the top face of the cone is. The top face has been highlighted with 4 hot spots. I'll place the mouse over one of the hot spots, and that is where I'm going to start drawing the base of the cone. Click, move the mouse to the other hot spot, click again, and then provide some height. I'm going to make it 1.75 inches high and click to finish. On the bottom toolbar, there is one tool that is highlighted at the moment, and that is Select All. I'm going to click it, and both of those objects both the cylinder and the cone will get selected. And the reason I've done that is because I want to group them together to make one object. I can either right-click on the object and click on Group, or I can go to the bottom toolbar again, the very left tool, which is the Group tool, and click on that. I'm going to do that now, and it's going to turn those two objects into one. And if you remember, earlier on, we used the rotate to turn objects over. That's what I'm going to do now. I've put my mouse on the object, right-click, I can see my context-sensitive menu. I'll find the rotate option, click on rotate. I'm going to choose the Z-axis, 180 degrees, and apply that rotation. And before, let me just move it slightly so you can see better what's going on. Before I finish the object and decide to print it out, I want to give it some texture. I'll click the object, select it, open up the palette window, and find a suitable texture. Here, I'm going to find a floor texture. We'll understand why in a second. But when I click on the palette and open up the textures window and open up the floor window, there's a floor pattern here which is called steel panels. I'll click on steel panels and that will map onto my cylinder and cone. So, there is the grain silo. Now, I've just seen the time, and so let me just explain what I was going to do next, and that is just make some strips of card which I could use to form some legs. I want to stick 4 legs onto the side of the cylinder and the cone so that it's raised and the truck can drive underneath it. Before I finish the design, I'm on the next page here. The net is just a little too large for the piece of paper that it's sitting on. So I'm going to right-click the net, and that displays some menu options. One of them is called Separate Net. I'll just give that a chance to appear on your screen. I'm going to click Separate Net, and then move the nets to a convenient position so that they can be printed out and built. I'm just placing the legs. The legs are quite tricky to make. However, one can do it. And there is our green silo. Now, it's a simple design, but it demonstrates that one can use ModelMaker to build concept designs for familiar things, maybe to redesign them. You can make chairs, furniture, pyramids, and in the process one has exposed all the pupils in the class to cylinders and cuboids and all the other math shapes and all of the math that goes with that. And maybe if you have such a thing as Mother's Day in Hawaii, a fantastic project would be to make a tissue box with patterns on it, and one can build it, take it home, and fill it full of tissues for Mother's Day. And without hardly realizing it, you've imbibed all of that knowledge that goes with the project, whether it be volumes and areas, lines and vertices, and all the other things that we teach in that lesson. Now, it's 9:15, Ashish. I think I'm at the end of our session. If you like, I can be open to a few more questions.
Okay, just otherwise, a quick question, Nick.
I'm happy to move on with the rest of you.
Peter wants to know that the Saturn rocket model that you made, is it possible to get a copy of that file?
Model that you made, is it possible to get
or is it like your...
Of course it is, Ashish.
The star of your show, so it's proprietary information.
Well,
the star of your show, so it's proprietary information.
Yes, well, we'll have to acquire
Alright, I see Peter up for that challenge.
Alright, I see Peter up for that challenge.
Yes. When David's in his session, Ashish, I shall email you the ModelMaker model for Saturn, so that before the end of the session you can have it on your screen.
Sounds good. Also, Jeffrey would like to know the features that you discussed today with ModelMaker. Are they available in the user manual that you have prepared?
Are they available in the user manual that you have prepared?
Itself? Okay.
Yes, they are.
Is available in the ModelMaker itself.
Yes, they are. All of the features that I've mentioned are in the manual, although it's not a tome. It's not a lengthy volume. We have found going into a local school that it's a bit like a word processor. It's best learned by experimentation and discovery, rather than trying to learn exactly all the features that it contains.
Great, thank you. Thank you so much, Nick. That presentation was really helpful.
Great, thank you.
And
thank you so much, Nick. That presentation was really helpful.
I myself learned a lot about ModelMaker today, so I'm going to be using it much more often.
I myself learned a lot about ModelMaker today, so I'm going to be using it much more often.
Thank you.
Cool.
So,
thank you.